Welcome to Falcon Physician Review's Neurology Review. The following section will be on brainstem anatomy. And this is a very difficult section, so I hope that you drink your coffee and you're ready to go. The first thing we want to tell you is that the brainstem, of course, is divided into three sections. That includes midbrain, pons, and medulla. The midbrain here is seen as the four colliculi on the back of the brainstem. This image is a brainstem image seen from the back with the cerebellum cut off. So now in the pons, instead of seeing the cerebellum, you actually are able to see into the fourth ventricle and the cut surfaces where the cerebellum was lopped off. Below the pons is where the medulla is, and you can see that there's very little landmarks to look at that to be able to say, oh, this is the medulla. It's just a round structure, although it's packed with important structures inside of that. Let's look at the front of the brainstem. Here you see a lot more details. At the top, what you see is the connection with the brain itself, and you see the pituitary gland and the optic nerve. However, below that you can see the large fiber tracts running at the base of the midbrain, known as the crus cerebri, also known as the cerebral peduncles. Down below that you see the bulbous structure of the pons, and smack dab out of the middle of the pons is where the trigeminal nerve, the fifth cranial nerve, is exiting. And below that you see the medulla. This part of the medulla has a lot of structures that you can view, notably being the central pyramids and the more lateral olives, and right between those two structures, the 12th cranial nerve, the hypoglossal nerve, is exiting. Looking inside of the brainstem, as if it were a glass structure, you can see where the cranial nerve nuclei would be. In the midbrain, you'll see cranial nerves 3 and 4, as well as a parasympathetic nucleus that is very closely associated with cranial nerve 3, called the Edinger-Westphal nucleus. Down below that, in the pons, you're going to see primarily cranial nerve 5 nuclei. There are many different components of cranial nerve 5, including mesencephalic nucleus, the main sensory nucleus, the spinal nucleus, and the motor nucleus. All of those guys play by the rules. That is, they are smack dab in the middle of the pons, as they should be with cranial nerve 5, except for the spinal nucleus of 5. Spinal nucleus of 5, as you can see in this picture, extends way down below, even to where, even can extend into the cervical spinal cord. So that's the one cranial nerve nucleus that really doesn't play by the rules. Going down further in the pons, we see cranial nerve nuclei of 6 and 7. I like to say that those two are very good friends because they're very close together, and you'll see how the fibers of 7 actually wrap around 6 before it exits the pons, the lowest portion of the pons. Now, if you look into the medulla, you're going to see a heck of a lot of nuclei down there. We call it I call it the Manhattan of the brain. It's where a heck of a lot of stuff is very packed in. So you're going to see cranial nerves of 9, nuclei of 9, 10, 11, and 12. You're going to see them all together back over there. Now, they're not always named the same thing as what, you're not even going to say, oh, this is nucleus of cranial nerve 9. You're going to see other components such as nucleus ambiguus, nucleus solitarius, the dorsal nucleus of the vagus. All those things are going to be introduced to you in this when I show you in the sections. First, I have to give you some terms that you need to be familiar with when you are looking at the brainstem. One is called rostral. Rostral means nose or towards the nose, and it's pretty much the same as superior or cranial or towards the cranium. It means higher up in the brainstem, or the pons would be rostral to the medulla. Okay? It is higher up or closer to the nose. Caudal is another term meaning closer to the tail. That would be inferior or below. Now, let's look at this section here, where you can see how the brainstem can be sectioned into rostral and caudal portions of each section. So sometimes we'll be saying, oh, this is from the rostral medulla, meaning the upper medulla, rather than being from the caudal medulla. When you see a brainstem section, the first thing to do is to not panic. There is a lot of difficulty with memorizing the brainstem anatomy, but I'm going to give you some algorithm to go through so that you will not panic when you see these brainstem sections. And you'll see that you can really narrow down the choices just by knowing some of this information from the algorithm. The first thing to do when you see a brainstem section, the next thing after not panicking, is to ask, which region am I in? Okay, and I'm going to give you some landmarks that you can look at that will be tried and true so that you can say, I am absolutely in the midbrain, or I am absolutely in the pons, or I'm absolutely in the medulla. And that will help a lot. Once you have that down, and you know where you are in the brainstem, you can start answering the question, are there any cranial nerves here, and can I see them? I'll show you those on the brainstem sections, and you'll just have to memorize that by brute force. However, again, knowing where you are in the brainstem is going to help you a lot because you can narrow down your choices. The third thing is, where are my three important tracts here? Those are the three high-yield tracts that we've talked about in the spinal cord, and we're going to talk about these in the brainstem. The three tracts are corticospinal, the dorsal column / medial meniscus, and the spinal thalamic. In the brainstem, the dorsal columns will be called the medial meniscus, but I like to link them together so that you'll never forget that the dorsal column and medial meniscus are always the same system, okay? Now, let's go through some of these slices. This first slice is a circle of tissue. Doesn't look very much different than the spinal cord. Well, then it would make sense that it is very close to the spinal cord, and this is the caudalmost portion of the medulla. And what you would see here is that cranial nerve 7, the fibers of cranial nerve 7, are wrapping around the area of cranial nerve 6, and that's why I say they are good friends, and they are here located together in the caudal pons. One section up, we see a different looking portion of the pons, but this is what I would call the classic pons. It has these classic striations of the basis pontis. Now, we've changed. Do we see any more olives? No, there are no olives in this picture, therefore we must be in a different region, and this structure is the lowest portion of the pons, or caudal pons. So I'll point out some important structures there in a second, but the most important thing, and the only reason why somebody would show you a caudal pons section, is because cranial nerves 6 and 7 are seen here. And what you would see here is that cranial nerve 7, the fibers of cranial nerve 7, are wrapping around the area of cranial nerve 6, and that's why I say they are good friends, and they are here located together in the caudal pons. One section up, we see a different looking portion of the pons, but this is what I would call the classic pons. It has these classic striations of the basis pontis, and this is where a large number of fiber tracts are going through, and I'll talk to you about that in a second. But first I want you to become very familiar with, when you see this kind of a structure with this striations across the front of it, you should be thinking that this is the pons. All right? The classic pons. So what cranial nerve should be around here? I would say, well, mid-pons should be 5, right? And we'll talk about that after a second. All right, now we go up north a little bit more, or cranially or rostrally, and now we see a structure that looks like an upside-down Mickey Mouse. You can think of the two ears seen here as a Mickey Mouse ears, and that is the only structure in the brain that has this kind of a look to it. So if you see this kind of Mickey Mouse, you know that you are in the midbrain. We go up just a little bit farther, we see another look at the Mickey Mouse structure in the midbrain, and there are some important structures here that I'll point out. Now, in the midbrain, let's look at some of the prominent structures here. The base of the midbrain is comprised of the crus cerebri. These large white matter tracts here are showing where the corticospinal tract is coursing through. Right above that is the substantia nigra, and on an unstained section, this is a myelin-stained section, but if it were unstained, you would see darkness there, and that's because of neuromelanin. If there's Parkinson's disease, you're going to see a loss of that neuromelanin, and we'll talk about that later. The structure above that, the large circular structure, is the red nucleus. So the red nucleus is an important structure there. Going in just a little bit more medially and is where the third cranial nerve nucleus is, and capping that would be Edinger-Westphal nucleus. The center of the structure of this, where there's an opening, is called the aqueduct of Sylvius. That's a CSF structure, and it is surrounded by periaqueductal gray. And then just at the very back of the midbrain, also known as the tectum or the roof of the midbrain, are where the colliculi are, the superior and inferior colliculi. Difficult to tell which is which, whether you're in the inferior colliculi or superior colliculi, but I would assume that we're in the upper portion of the midbrain here, so these must be superior colliculi. They are the bumps or hills on the back of the midbrain. So again, here we are in the caudal medulla. The main structures that are going to be here are the following. Fasciculus gracilis, because we're still just below the area where that fasciculus is going to synapse in the nucleus gracilis. And just that pale area right at the end of the arrow is where the nucleus gracilis is going to be. Fasciculus cuneatus is right here where the dark structure that the arrow is pointing to. Spinal nucleus of 5, so this is the one cranial nerve, that nucleus that really doesn't play by the rules. We're way down in the caudal medulla, and cranial nerve 5, the nerve itself, is nowhere near this. It's in the mid-pons. However, the spinal nucleus of cranial nerve 5 can be found well below where the pons is. And here is the pyramidal decussation, the crossing of the corticospinal tract. Let's go up just a little bit, still within the caudal medulla, and point out some structures here. Nucleus cuneatus is now the gray matter structure this arrow is pointing to. Nucleus gracilis is the gray matter structure that this arrow is pointing to. The spinal nucleus of 5 is again seen here. And the inferior olivary nucleus. This is going to become a very close friend of yours, because when you see this inferior olivary nucleus, you know you're in the medulla. And that structure is going to help you immensely when you are trying to identify brainstem slices. If you see the medullary olive, you are in the medulla, and therefore that will narrow down a lot of your choices. And here's the pyramids, part of the corticospinal tract. Again, now we're in the rostral medulla, and you see very clearly the olives here. First, I'll point out the inferior cerebellar peduncle, a white matter tract that's primarily entering into the cerebellum. An inferior olivary nucleus, again, the friend that will tell you that you're in the medulla, and the pyramids, corticospinal tract. Here's another look at this. Same structures, inferior cerebellar peduncle, inferior olivary nucleus, and the pyramids. In addition, this particular slice happens to be catching the foramen of Luschka as the CSF exits the fourth ventricle seen at the top of the slice. Now we're out of the medulla because we don't see any inferior olivary nuclei, right? Well, here are the structures that we should point out here. One is the superior cerebellar peduncle. That's just above the fourth ventricle here. The facial colliculus is made up of the fibers that are surrounding cranial nerve 6 as they exit. So cranial nerve 7, the facial nucleus, or the facial nerve, will send its fibers up and around cranial nerve nucleus of 6, and that creates a bump within the fourth ventricle, which is called the facial colliculus. Here is the middle cerebellar peduncle, and here are the pyramids just as they're beginning to form. That concludes concludes our Brainstem Anatomy section of the Neural Review for Talc and Position Reviews. That concludes our Brainstem Anatomy section of the Neural Review for Talc and Position Reviews.